Hello everyone, welcome to this video. In the previous video we have studied about this result which states that every permutation in a permutation group that could be written as product of two cycles, that is transpositions. And what is the way to do so? If we have a cycle of the kind a1 a2 up to ak, we can represent and write it like this: a1 ak, then next element would be a1 ak minus 1, and we keep on doing like this until we reach at the last element a1 a2, right? So this is the way. So let's move on to the example here. The example here, it is this permutation where 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 5, and 5 maps back to 1, right? So this is the given permutation. We may write this according to the above form as: with 1 the element 5, this forms our first transposition; with 1 the element 4, this forms the second transposition; with 1 the element 3, this forms the third transposition; and with 1 the element 2, this forms the last transposition. So how this is there, you can check this. Suppose we wanted to check what 3 maps to, is it mapping to 4 here? So we will start by taking 3 here. So you see 3 maps to 1 according to this cycle, and 1 maps to 4 according to this cycle, and 4 doesn't map to anything. So that means your answer is 4. So obviously 3 is mapping to 4. So this is how we have the result. And moreover, this is not the only way by which a permutation can be written as product of two cycles. We can also represent the same permutation as the product of these cycles. So how this is there? How we is it always equal to this thing? So let's verify this thing. So for that we will check that every element, is it mapping to the next element or not. So we have to check whether 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 5, 5 maps to 1 or not. So we just have to verify this thing by taking the left hand side as well as the right hand side. So in the left hand side, you see you can write your cycle like this: 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 5, 5 maps to 1, right? Now we have to check what is there for in the right hand side. So in the right hand side, do we obtain the same thing as the left hand side? So let's verify. Our left hand side, our right hand side is this one. So we have to check under this mapping, under this permutation, what is the value of alpha of 1, what is alpha of 2, what is alpha of 3, what is alpha of 4, what is alpha of 5, and based on this we will construct an array of this kind, and then we will compare our constructed array from the right hand side. Is it equal to the array on the left hand side or not? If that is so, we have both these permutations as equal to each other, right? So let's see in the right hand side what is the value of alpha of 1, right? So alpha of 1, this could be calculated by writing down the permutation here, right? So we start by inputting one number to it. So in this case we have to move from left to right in this case. So this is what we'll be doing here. So we are inputting the number 1 here. So you see this first member here, shift or move 1 to the digit 3, and the second member here move the digit 3 to the digit 2. This third member here move the digit 2 to the digit 5, and this member here move the digit 5 to 2. So you see, and there is no 2 further on, right? So that means this 1 is now having the value 2 finally. So you see alpha of 1 is your 2. So in this array we obtain 1 maps to 2, right? Let's see for the next one. For the next one, we will input the number 2 here, and we'll see what do we have here. So there is no 2, so this does not create any effect. Here is 2, and this 2 maps to 3, and here is no 3, here is no 3, here is no 3, here is no 3. So 3 is your answer. So that means alpha of 2 is 3. So we have alpha of 2 as equal to 3 here, right? For the next one, we wanted to check what is alpha of 3, right? So we input 3 here. So you see the first cycle here shifts this 3 to 1. There is no 1, there is no 1. Here there is 1, and this 1 send to 2. So here there is 2, we will be looking at this 2. This 2 sends to 5, and here there is also 5. This 5 moves to 4. So 4 is your final answer. So that means 3 maps to 4. So alpha of 3 is 4. So that means we have alpha of 3 as 4, right? For the next entry here, we are inputting the number 4, and let's see what do we have. There is no 4, there is no 4, there is no 4, there is no 4, there is no 4. We have 4 here, and 4 shifts to 5. So that means we have the answer as 5. So alpha of 4 is equal to 5 here in this case, right? And for the last one, so 4 maps to 5. For the last one, we are inputting the number 5 here. There is no 5, there is no 5. Here it is 5. So this 5 is sending us to 2. So here we have 2, this 2 is sending us to 1. So there is no 1, there is no 1. So our final answer is 1. So this 5 maps to 1. So you see, this is our value of alpha in the right hand side, right? So we have to match whether the right hand side is it equal to the left hand side arrow. So so the cycle here, it is basically 1 goes to 2, 2 goes to 3, 3 goes to 4, and 4 goes to 5, 5 come back to 1. So this completes our cycle. So in this case, this array is exactly equal to the array that we obtained in the left hand side. Hence both of them, they are equal. Hence both of them represent the same permutation. So I hope you understood this example well. Well, that is it for this video. Thank you for watching.